Hello friends, welcome to the Tech Granth. Today we will talk about the system design for video streaming application, and these applications are like Netflix, YouTube, Amazon Prime Video or Hotstar. So let's go into the requirement for this system design. So in this particular video I will not talk about the requirement or anything related to user onboarding or a content provider onboarding or how those service will work, because these things are very common across different systems like a streaming application or maybe a Facebook kind of application or an Instagram kind of application. So the user part will always remain same, but what I feel is that when an interviewer is asking you about a system design for video streaming app, so these three are the uh, primary functional requirement which we should cover, and they are how you will onboard a video, how you will search a video, and how you will view a video. Now viewing the video is little tricky because the view should be a seamless view, and that is why the non-functional requirement side says that you should have a real-time experience. So we'll talk about onboarding video, searching and viewing with real-time experience. And we also need to consider availability and reliability as two factor of the non-functional requirement. We'll not talk about consistency because we want our system to be highly available and reliable. Consistency can take a hit. Why consistency can take a hit is because suppose you uploaded a video and the viewer he can watch that video, or that video can be made available to one of the subscriber after an hour or so, so that will not affect anything to the viewer or to the content provider. So that is why consistency here in this particular case can take a hit, but it should be highly available and the system should be very reliable. So these are the requirements that we will cover in this particular video. Now let us talk about the first functional requirement, which is onboarding of our video. So how we will onboard the video to our system. So this is a small design for onboarding any new video to our application. So there will be a client here. Let me take the laser pointer. So here we will have a client. So this client can be you or me or anyone who is uploading a video for others to view. So this guy will upload the video, and how the flow will work in this case is the client will pass on the video that he wants to upload to an upload service. So this upload service will it will have an endpoint which will be, this will be a microservice basically, and the endpoint will be exposed to the clients. Now whenever client uploads a video, so this video can be a very big size. So what we will do is we'll pick up that video, we'll put it in a distributed storage. Now this distributed storage can be a cheap storage like Amazon S3 or a distributed file system kind of storage. So what this upload service here will do is it will pick up whatever client wants to upload. It will pick up the complete file and it will put it in our distributed storage. What this also does is it will put a metadata in a database here. Now this database can be a relational database like MySQL. So what it will contain is it will have a table which will tell that what is the video that we are uploading, who is the author of the video, and what is the URL in the distributed file storage. So things like these can be put in a like these metadata can be put in a database here. So once we are done with the upload here into the distributed storage, our onboarding process will start after this. So what will happen is once the upload service has added the video in our distributed storage, it will put an event in a distributed queue here. So this distributed queue will be the core of our application, and everything will be directed through this particular queue. So this has to be a highly reliable queue and it has to be very efficient. So we can use a queue like Kafka here for our distributed queue. So what this upload service will do is once it has stored the video in distributed storage, it will put an event here in the queue saying that I have stored the video. Now anyone who is ready to do the processing for this particular video can pick up this particular event. So the next thing is a video splitter. So this video splitter will be listening to this queue for an event from upload service, and that event will be that the video has been stored in distributed storage. What this video splitter will do is that, as the name suggests, it will definitely split the video. So why we require video splitter is because of mainly two reasons. First is that the video that will come from the client, so that video can be a very big video. A big video means that the size will be huge. So suppose you and I make a video using a normal camera phone, or maybe a good quality camera. So that video can come up to like an hour long video will come up to a size of like 2 GB or 3 GB. But maybe someone with a professional camera, he or she is capturing a video, so that video or a movie kind of thing, so that can be of size like 50 GB or even more. So it will be very tough to stream the complete video or even do some processing on that particular video if it is just one big file which is present with us. So it's very important that we split that video file, and like I told, there will be two major reasons. One is because it will give you an option to parallelize certain operation that you will do further down the line on the processing of this video. Second is, when you are streaming the video or when the client is watching that video, you don't need to send the complete 50 GB or 60 GB video to the client. You can send it in like chunks. You can send the first part. Once the client or once the user is at the end of the first chunk, you can then give up the second chunk of that particular video. So like that, there are more things that we can do. We'll talk about it later in this particular video. So that is the reason why we require a video splitter. So what video splitter will do is it will divide the complete video into smaller chunks. So you can think of it like if there is a video reel here, and this is of like an or this is like a 10 minutes video. So maybe we can split it into like smaller parts like these. So it can be split into 10 parts, and each of these can be basically used for further processing. Now what is the further processing? So once this video splitter has split this big video into smaller or small 10 chunks, it will again put an event in the queue saying that okay, I have done my job and I have split the video into smaller chunks. So next in line will be this encoder service. So what this encoder service will do is it will pick up these chunks. Now here is the thing, here why we require the video splitter to split the video into smaller chunks. Now when encoder service has to encode this video, it can basically parallelize its operation. It can pick multiple chunks together and do its processing. So that is the encoder service. Now the thing is why we require an encoder service. So the thing is, in today's scenario, if you see, if you are uploading a video on YouTube or Netflix, or if you are creating your own streaming application, so that application will be used by multiple clients. Now what multiple clients are, like whatever client you are using, it will be running on multiple kinds of device. So different kind of devices like a TV, a laptop, or a mobile phone. Now each of these device will have its own resolution, and each of these will have their own processing power. Not the processing power, basically the power with which the refresh rate that it can handle. So all those things will be different for different kind of device. Now the second thing is that each of the device is being part of a network. So every user will be part of some network, because he will be connected to internet to pull video from your system, right? So what will happen is that each of the user will have a different bandwidth. So some user will have a very fast internet, so they can stream a high resolution video very easily. Some of them will be running in a lower bandwidth, or their internet connection will be slow. So for them, they might not be able to they might not be able to stream the high resolution video so efficiently. But as per our requirement, the video that we have to the user has to view the video in a real-time experience. So maybe for them a smaller a lower quality video needs to be supplied to them. So by lower quality video means that a compressed video which will have a smaller size. So if the initial video was of like 50 GB, we can compress it into multiple sizes, so that some of them are like 40 GB, some are like in MBs, so that they can be given to the client with lower bandwidth. So what this encoder service will do is it will basically encode the video that was split initially into multiple formats. So it will do two things. One is the format. So these formats are like you might have seen AVI or FLV or like that, FLV or MP4 kind of format. So what this will do is it will take all those smaller pieces of the video which video splitter splitted, and it will convert each of them into multiple formats. So each of these format will have its own encoding algorithm, based on which some will be like a high resolution video, others will be like a low resolution video. So this encoder service, first it will basically convert it into different formats, and second thing will be resolution. So for each of the format, the encoder service will convert to each of the smaller pieces of the splitted video into different resolution also. So this resolution is like 180p or 720p or 480p. So once the encoder service has done its job, so suppose this video splitter splitted the video into 10 part. So first part was named 1, second part was named 2, like that. So after encoder service has done its work, so we will have a video called 1.FLV, and this will be of resolution like 180p, something like this. Then there will be another video which will be 1.FLV, and this will be of resolution like 480p. So, and similarly we will have like 1.AVI, 1.MP4, and each will have their own resolution. So overall each part will be multiplied into various format, and it will be F cross R times. So means the number of format that we are supporting into the number of resolution that we are supporting. So if we are supporting these two formats and two resolution like 1080 and 480p, so first part will be split into four formats, which will be 1.AVI 180p, 1.AVI 480p, 1.FLB 180p, 1.FLB 480p. Like that, the video has to be split into multiple formats and into multiple resolution, so that it can be supported across different devices, and that is how we will be able to serve a real-time experience. We will be able to give real-time experience even to the person who is using a mobile phone or any device which is working on a low latency in a low bandwidth kind of internet connection. So that is why an encoder service is required here. So once the encoder service has done its job, it will again put an event in this queue saying that I have encoded all the videos. So it means that I have in my storage, I have for the video which you uploaded, I have the details. Basically I have converted each of the small videos or the chunks into different formats and into different resolution. So once this guy has finished that, it will also put an entry here. It will put an entry into this database saying that for the video, what is the original video. So the original video was video 1, I can say V1. So for V1 I have a chunk 1.FLV and of resolution type 1080p, and the path of is whatever the URL wherever it has stored. So in the table it can basically store this number. So for video 1 FLV and 480p, so something like this can be stored in the tables to maintain the metadata that where exactly is the each of the chunks is lying in the distributed storage. So that information will be stored in this particular database that we have. Now once we have stored the chunks into the storage and we have the information here in database, so by now we are ready with the processing part. Next thing is that we need to verify the content. Now once encoder service put an event in queue saying that okay, encoding is done, then the content verification service will be triggered, and what this guy will do is, and these two operations will go in parallel. So as and when this guy, since this guy is working in parallel, it will be putting an event in the queue saying that okay, first chunk is done, second chunk is done. So whenever first chunk is done, content verification service, it will pick up this particular chunk and it will start processing that. So anything after this encoder service, all these will be done in a parallel way, and that is the main reason why we splitted the video in the first place. So what this content verification service will do is it will verify what is the content of the video. Now to verify that, there will be some algorithm and some rules that we might have set, saying that the video should not contain any offensive kind of language or abusive language. It should not contain nudity, or it should not contain anything which is really violent, or it can basically provoke someone. So those kind of thing will be coded as part of this content verification service. And for each of the chunk, if something like that is found, so it will be basically blocked. So that video will be blocked and some notification will be sent to the client saying that your video is not up to the mark to be uploaded. Otherwise, the content verification service will again put a notification in this queue saying that the contents are okay, it's good to go. So the next piece of the puzzle here is the Video Explorer service. So why Video Explorer service is important is because it will be able to uh, create some tags for your video, and it will be able to pass on the metadata to the Elasticsearch, based on which your video will become searchable. So what this guy will do is, whenever a client has uploaded a video, so client will be uploading the video along with some detail. Now that detail will be a small description of the video saying what is this video about. If it's a movie, it will give a small briefing about the movie. It will tell about what are the cast for this movie, who is the director, producer, and what is the genre of the movie. All those details will be passed on by the client. What this Video Explorer service will do is it will parse all those things and it will pass it on to Elasticsearch. Now the benefit here is that if suppose someone wants to make a search based on different scenarios, like the straightforward case is that someone would like to uh, search for a movie, so he will just type in the movie name. But there can be a case where someone wants to watch a comedy movie, or even you as a video provider or a content provider wants to basically create a playlist kind of thing where you will put like, okay, these all are under a comedy movie, these movies are under a tag of thriller, and all those kind of thing. So what this Video Explorer will do is it will attach all those different tags to your movie and it will put it in the Elasticsearch. Now what Elasticsearch will do is it will have a table kind of structure, and it will be something like for suppose for horror, it will have a name. Your movie name is here. Suppose tomorrow someone else uploaded a movie and it found a tag horror, so that again next to the horror tag, your movie or the new movie that was there, it will be appended to this particular movie. So when someone search for this horror, everything which is there as part of the horror tags here, let me just put it something like this. So I have a horror here, and then there is a list of horror movies as part of the Elasticsearch. So we have movie 1 which I uploaded just now, and tomorrow someone else uploaded a horror movie, so here M2 also will be appended as part of this. So if someone has to search for a horror movie, what our system has to do is just look for this horror tag and return whatever list is here and paginate it and send it back to the user. So that is how this Video Explorer service will really be helpful, and it will help us in making our video really searchable. And this has to be really efficient, because there is no point having a video which a user cannot search, because if someone search for a movie 1 and the result that he's getting is totally absurd, then no one will like to come to this video streaming site. So that is why this service is really important. When this guy has done his work, it has tagged all the videos, and it has worked on the various tags that are present as part of the video. By tag I mean that whatever has been passed from the description, title, and the genres and everything. So once this is done, it will put an event back to the queue saying that I have completed the exploration of this particular video and it is now ready to be distributed. So once this thing is done, then video distributor service will come into picture. Now what is the use of this video distributor service? The use of this video distributor service is to pick up the video from the main storage and pass it on to some cache storage. Now, what does this mean? This means that suppose you have a system like a Netflix or a YouTube. So these kind of system are present across various countries. It's like Netflix and YouTube. They are present in like 200 countries. Now, this distributed storage will not be there everywhere. It will be present in one particular place. Say if it is present in North America, so this storage is present in North America, and if someone from India is trying to watch a video, so it will be really costly operation to make a call to the distributed storage all the way across North America and stream the video from there, because video files will still be very large and it has to be streamed seamlessly and we should have a real-time experience. So streaming the video from there to India, it will be a very costly operation. So that is why there is a concept called content delivery network called CDNs. So it will be something like this, which is present here. So suppose the main server here is present in North America, is not present in North America, it's present somewhere in Europe here. So from Europe, the delivery will be distributed. So we will have some edge servers or cache server which will be present in like North America, in Iceland, or South America, Africa, in Australia, and in India somewhere. Now, what is the use of this video distributor service is it will look at the video that has been uploaded, and it should have some algorithm which will, based on the type of the video, it will basically distribute the video into one of these or multiple cache server. So this cache server here, for example, we have shown like there are some 5 or 6 cache server that are present, but in reality there will be like thousands of cache server which will be present. Now it's not a good idea to distribute all the videos across all cache server. The reason being, these cache server will be very local to the region that they are present. So if suppose someone has uploaded a Bollywood movie, so it makes sense to put that particular movie in the cache server which is present in India, as compared to the cache server which is present in Africa, because more people in India will be watching the Bollywood movie as compared to those in Africa. So what this video distributor service will do is, during an offline hour or less loaded hour, it will pick up that particular video and it will load it into these cache servers. So it can load it into 1 or 2 cache server, and it can happen in a cascaded way. Like suppose I have uploaded a Bollywood movie into India cache server. So someone in Australia, rather than going all the way to Europe, they can basically pick it up from the cache server of India. They can make a check whether that movie is available in India's cache server or not. If it is present, just pick it up from there. So it can be basically distributed in this particular fashion. So that is why distributor service is really important. We'll talk about this CDN in more detail later down the video. Now this picture I have picked it up from internet, so I don't have any authority over it. I have just picked it up for explanation purpose. So this is the whole process of how a new video gets onboarded into a streaming application. So I hope this part was very clear to everyone. Next part is search. So search is very simple because of this video explorer service. So this video explorer service has put everything, or it has passed everything and it has passed it on to Elasticsearch. So whenever this video has to be searched, so there will be a search service. It will talk to the Elasticsearch, and whatever is the response of Elasticsearch, it can pass it on to the device, or it can pass it on to the user. Now the benefit of Elasticsearch here is that when you are searching for a movie name or a long video name, then there is a high chance that you will make a typo, And Elasticsearch, basically it handles all those cases perfectly. It gives a solution out of the box for such kind of operation. So that is why this search service will use an Elasticsearch, and it will be really efficient. Now there is one thing which is not covered as part of this video, but I just wanted to bring it to the notice because even YouTube has put it as part of one of their video, which means the relevance of a search. What relevance of search means that suppose there is just one word, it's called cricket. Now if someone searches this word, he can get a list of video like this which is relevant to the cricket match, or he can or she can get a list of video like this which relates to a cricket which is insect. Now how these two will be distinguished is based on the search history of the person who is making a search. So if the person has previously made a search for sports related activities, then when he or she types cricket in the search box, he will be returned with something like a list like this or a page like this. Whereas if someone was interested in wildlife, or he was searching for a video based on some animals or insects, in that particular scenario, if that person make a search of cricket, they might get a response like this. So YouTube has this feature, but it may not be necessary to include as part of the interview, but uh, just for information purpose, I wanted to include it as part of our search service. So this is how the search and onboarding. Last part of the video is the viewing service, like the client who is present, or someone from their mobile or laptop or TV, they want to view a video. So what they will do is they will select the video to play, and once they select, how the request will flow is the request will go to the ISP. ISP is your internet service provider, and when you send the request, you will send it with the URL slash some name of the video and some other detail. But how that URL will be routed to the application that we have is because this ISP will have a table on their side which will have a mapping. So if you want to open Facebook, so you will type facebook.com, and ISP will convert facebook.com to the corresponding IP address of the Facebook server that is present. Similarly, for us, whatever URL that has been passed, it will be routed to the application server's URL by this ISP. So this guy will route that request to our service. On our side, we will see that okay, it's a get request. So what we need to do is for that particular movie that has been requested, we need to pick it up, and we'll pick up the first chunk. So you remember we splitted the video into multiple chunks. So first chunk of that video will be picked up, and that metadata will be available here in our database, and the actual path will be present, or the actual video will be in the distributed storage. So that part of the or that chunk of the video will be sent back to the guy here. That will be sent back to the device here to be played. Now the problem here is that this distributed storage, like while onboarding we talked about this distributed storage being present in only one place, and it was present in the diagram that I showed, it was present in somewhere in Europe. So if this guy is making that request, it will be very tough for us to make a seamless service or a real-time experience for this guy, because once that chunk of the video is finished, the next chunk has to be sent back to this device, and there will be lot of traffic on these network, because it's not just us. There will be like thousands or millions of basically thousands or millions of guys who will be routed through a same ISP, and this network will get really congested, and the real-time experience thing will not be there, and there will definitely be a slowness, and the buffer time will increase. So the solution for this is whatever we discussed during the CDN, that will put some cache server in each of the zone locally. Now where exactly we'll put that particular cache server? So that is at the ISP level itself. So this concept was brought by Netflix. Now YouTube also uses it, and this is actually a very good practice. So what we can do is, like, rather than storing, we will have everything stored here as a true copy in the distributed storage, but based on the traffic of certain video, we can basically cache it at the ISP itself. So if I'm going for, or from this particular ISP, the request is, a lot of requests is there for Bollywood movies, so we'll cache all those Bollywood movies here. So next time when anyone who is subscribed to this ISP, when they make a request, rather than going all the way to the Europe where our distributor storage was, they can get the video directly from this cache that is there at the ISP level itself. So from here the request can be returned, and all the chunks will be cached here. So this can be a normal storage, a cheap storage, and the whole purpose of using or maintaining this is that user will have a seamless experience, and the network congestion also will be less. So everything, like the millions of requests that was coming from all the user through this ISP to this get video service, now everything beyond this point will be not in use, because I will serve the request from here itself. Now if suppose I did not find that video in my cache, so in that particular case I will go to the distributed cache, distributed storage. I'll pull the first chunk of the video to play here, and subsequently all the chunks of video for that particular file, or some chunks of the next set of video, can be cached here into this ISP cache. So that way next chunk of the video can be served to this particular user from this cache itself. So that way the service will be really seamless, and you will get real-time experience. Now the second thing is, remember we basically split the video into multiple smaller chunks and we converted into different formats. So one reason for converting that into different format was to support different kind of device. Suppose someone wants to watch a video on their TV with very high bandwidth of internet, they can use MP4 in 1080p format. If someone wants to watch it in a lower bandwidth on a mobile or a very small screen mobile, they can basically go for some FLB with 480p kind of format. But the second thing that is where that will be helpful is, suppose this guy had a very good internet, and he was watching the video at 1080p resolution video. Now what happened is that in between he had a fluctuation of internet, and the bandwidth went down, and he had basically a slow internet connection. So in that case what can happen is, our application on the client side, it can sense this, and next time when it requests for a video, rather than requesting for a 1080p video, it can request for a 480p video, which will be a more compressed video, and the resolution can be a lower resolution video, so that this guy can basically watch the video seamlessly. Maybe he will watch the video, the quality of the video will be low, but there will not be any break in the experience that he is facing. So it will not be that the video was played for 5 seconds, then for another 5-10 seconds it was buffering, then again it was played for 5 seconds and it was buffering for another 5-10 seconds. That will not happen. It may happen that the bandwidth will be, since we are showing the low quality video here, so the quality of the video he will be watching will be in a low quality, but there will not be any break. And next time when the internet speed goes up or the bandwidth increases, so the next chunk of the video that we can send to this particular client can be again a high resolution video. So that is another benefit of formatting the video or encoding the video into different formats. This is how basically it will come together and it will look like. So we will have a client, an ISP, it will have a cache like CDN here. From ISP, the load balancer will be the entry point of our application. We'll have upload service, we'll have get video service, and we will have search service. So all these things will come together like I explained, and basically this is how I came up with a design for a streaming application. Let me know whether you liked it or not, or what was missing from the video. Do like, share and subscribe to the channel, and that's it for this video. See you in the next one. Take care. Bye.